Okay, so a couple of things today. Areas of triangles, and then we're going to move on to sine and cosine rule in our 2 lessons. So, first thing, area of a triangle. It probably won't take us too long actually. So, do you already have a formula for the area of a triangle? What is it?
Base times height divided by 2.
Base times height. What I'm going to do is times it by a half is the same as divided by 2. Yeah? Half base times height. Okay? So that's the area of the triangle. Now, just to be sure, how do I identify base and height? Because that's obviously quite important. How do you define the base of a triangle?
How are you meant to describe how to define the base? It's like on the bottom.
Well, she knows. Ever watch a QI?
That's the one with the...
Yeah, with Stephen Fry, and when someone says the obvious answer, it flashes up with yeah.
But how are you meant to explain that?
What would you say?
The height is perpendicular to the base.
Okay.
Oh, shut up.
That's how you explain it. The height is perpendicular to the base. So actually the base can be any of the sides that you like, as long as the height measurement is perpendicular to the base. Alright? So you can have this as the base. Alright? But if that's the base, the height will be to that point measured perpendicular. Okay, so that would be the height.
It's perpendicular 90 degrees.
Yes.
Okay.
So, if we have, though, let's pick a different triangle, slightly different. Okay. If I specify to you that this side is the base, children at the back, write on your own books. And now that's recorded and on the internet, just to let you know. Okay. So again, the base is now this side. It might just be defined as that's the one I know. Okay. So where would the base be now? No, sorry, that's the base. Where's the height? So we have to go from this point and we have to find it. So that could be, that would be the height. So don't think of base as the bottom and height as how tall it is. Okay, they're just 2 values. Okay. In the same way that if you've got a triangle that looks like this, it tends to confuse people. Let's say if I call this the base. Okay. What would be the height?
Would you go the top end? You go down 90 degrees like this.
Yeah. Okay, so if we were to extend the base, okay, so this value would be the height there. So the height doesn't have to be in the triangle, okay? Doesn't have to go across the triangle. So half the base times the height is how you find the area of a triangle. However, what if you don't know the height? Yeah, so you're all going, oh, that's not fair. So, go back to this triangle. Okay. going to go for, I'm going to have a number 10, whatever it is. I'm going to call this 8. I'm going to have an angle of, I don't know, what should we have? 38 degrees. I've just made it up.
Oh, wow.
Okay, so there is a triangle. I do not know the height. I've got a choice of bases. I've got an angle that you might say, well, it doesn't matter, I don't need the angle because it's base times height, it's nothing to do with the angle. Okay? But we could use it. So, what do you reckon, Eva?
You can make a line from the corner to the line that's 10.
Okay, so from here to there.
Yeah.
Okay, so I'm going to go down to there.
That would be a
And make it solid then. Okay. So we then end up with 2 right angle triangles.
Now we can find out that side.
Which side? This side?
Yeah.
Okay, so I'm going to call it height. Now I'm just going to write here, area always will be a half times the base times the height. Now, in this case, what has Ivan decided for us? Okay.
The base and the height.
Well, so what's the base?
10.
10. Okay. The height, we don't know what it is yet. Alright? But we're going to work it out. So, by drawing it in, right? By drawing it in, we've now got the ability to solve for what the height is. So what is the height? How do we work it out?
Use Sokotoa. So you do.
Okay, yeah, so Sokotoa. Let's just go through the motions. Sokotoa. So theta opposite adjacent hypotenuse. What do we know? Theta is 38. The opposite side is H. The adjacent side is
8, 10.
I'm not writing it because it's
Oh
not
no,
10.
10 minus something.
10 minus something. Do we know the adjacent side?
No, we don't.
No. That's the thing to be careful. That is not 10. I put that little line in for a reason.
I didn't
Okay.
see it.
That's you didn't see it. Okay.
That has to be less than 8.
It has to be less than 8. Do we care?
No.
That's the one we don't care about
No
this
one
time
cares.
because I know the hypotenuse is
8.
8. So actually, those two can go. So we've now got sine of 36 equals. Sorry, I couldn't see it. Opposite over hypotenuse, so that's h over 8. So if we rearrange to give it in terms of h, we have 8 sine 38 is h. So that's the height. So I'm going to put it in there, back up in here, right? So we go times 10 times 8 times sine of 38. Okay. Now, obviously, this will work if I know any of the 3 angles. I'm not actually interested in the answer. I'm interested in the result, the equation that results. You can all work that out in your own time. Okay? But what we're trying to get to, I could find a different angle, know a different angle. Okay? Now the thing that we've got to figure out is which things do I need to know to work out the area. So, for instance, I've got the base, which is 10. I've got the angle 38, okay, and I've got the 8. Now, let's think. If I knew this side and not the 8, would it have worked in this way? Would I have come across any kind of problem?
the side on the other end is in a different right angle triangle?
Yeah, so you notice that what I needed was to be able to solve a right angle triangle. So I need the sides relative to the angle within that right angle triangle. So if I knew that side and not this one, I still couldn't solve that one, could I? I wouldn't be able to solve for anything in there. I wouldn't be able to use, because there's no angles. And I can't guess what they are. I can't guess this side. So that leads us to an important point. To be able to do this, we can come up with a formula, which is what you'll see, which is a half AB sine theta is a new formula for the area of a triangle. Okay? Where that's a half, that's A, that's B, and you obviously got sine of theta. Right? You can see why it's always sine, because of the way it's been built up. But what is important is which sides are used as A and B. Right? So, we can say the area equals a half AB sine theta, where A and B are, what would you say? What would you say A and B would have to be to make this work?
Height,
Pardon?
are not height.
Well, no, exactly. They're the sides of a triangle, but it's also not that one. So what would you? How would you kind of say to someone, this is the situation we need to have? Right, there's a few blank faces. So let me kind of, before we write that, let's have a look at triangle. Okay.
It's not the opposite.
I'm going to give you, like, here's a triangle. If I said to you, I don't know whether this triangle works or not, I'm completely making it up. So 7, 9, 4. Okay, let's say this angle is, what should we say, 84 degrees. I might not even make a triangle. I'm just making up numbers off the top of my head. But just for the purposes of checking, if I asked you to tell me what the area of that triangle is using a half AB sine theta, if I asked you to put the numbers in, what would you tell me to do? What would A and B be? 7 and 4. Why?
Because it's next to the angle.
Because it's next to the angle. Okay, so it's going to be 7 times 4 times sine of 84. Okay. Alright, so that's the deal. It's the sides either side of the angle. So we could write that, so when A and B are either side of the angle theta. So they have to be either side. What we can say, in another way, is to say theta is the included angle of two sides, A and B. Now that word included means A and B are either side. They make the angle. Okay, so the two sides that you need to know are the ones that make the angle that you're dealing with. Alright? So that third side doesn't come into it. Apart from the fact that the length of that third side determines the angle in the first place. Alright? Because 4 and 7 on their own could make a lot of triangles, an infinite number of triangles. But this angle is determined by that side, and for that sort of, we don't then need it to work anything out. Okay about that?
Yeah.
It's actually very simple. You've just got another formula to remember, not hard ones. For me, it's a really easy one to remember. You've just got to remember which sides and the angles to use. Okay. So, which page was it on? 590 something. Which one is it? So it's actually 584. Guys. Still going, Ishan. You're ignoring me. Parents' evening coming up. Page 584. You've got the exercise 29B, right, for area of triangle. You've got a few questions there. Off you go. We'll go through them in a bit. Recording. Okay, first one. You should have half times 12 times 30 times. I'm sure you've done it on your calculator. What answers have you got?
55.2 centimeters squared.
55.2. Okay, so if we round now, there's the thing to notice. The answer itself, I'm sure you're going to get the right answer. If you've got an answer that looks strange, check that your calculator's not on radian mode. Okay. If there are units in the question, there must be units in the answer. Okay, so if you didn't write them in a test or an exam and they're not already supplied, you lose a mark. Okay. So you've got centimetre squared, kilometre squared. The next point is, if it asks you to round it, you should round it. All right, to a certain degree. If it says specifically in a question, round your answer to the nearest whole centimetre squared or the nearest decimal place, and you don't do it, you lose a mark, which is a silly mark to lose. So just to remind you. Okay? So, any problems with the areas of a triangle? No? Okay. Can you all maybe just have a go at the very last question if you're not already there? Go straight to that last question and do it.